Hey guys, this is Stratton. We're just going to walk through some counting of atoms together. I'm just going to show you a step-by-step process how each of these works. So follow along with me, do this on your own paper, and we'll get it knocked out. So the first thing we're going to do anytime we are counting atoms is we are going to write out the elements that we see present first. So we have two elements here. We have sodium and we have chlorine. Now, notice that these are both an uppercase and a lowercase letter. So uppercase letters can stand alone as a chemical symbol. The lowercase letters cannot. If you look on a periodic table, you will not see a lowercase letter on its own anywhere. So anytime you see a lowercase letter, it belongs to the uppercase letter in front of it. Now with both of these, we have no subscript, so we have no tiny number behind telling us how many of each element there is. We have no coefficient in the front, so we know that there is an invisible 1 behind each of these. So that means here we only have 1 sodium and 1 chlorine. All right, let's go to the next page, or try to. All right, so now we have one that's slightly different. Again, not anything crazy, but we have nitrogen and we have hydrogen. So again, we have two elements here. Behind the nitrogen, we have no subscript, so we have an invisible 1. We have 1 total nitrogen, and we have this 3 that belongs to the hydrogen, so we have 1 nitrogen and 3 hydrogen, giving us a total of 3 atoms. All right. So let me erase this mess. Now, on this one's a little bit different because we do have a coefficient. So we're going to start this one just like we do all of the others. So we're going to start by writing out the elements that we have present. We have barium and we have chlorine. Now, at the beginning, we are going to ignore this coefficient. We want to know first how many of each atom we have in one molecule before we figure out how many total atoms there are. So we have 1 barium, so we're going to put 1 here, and we have 2 chlorine. But now we're going to have to take into account our coefficient. So what we're going to do now is we're going to multiply our 3 to each of these. So this means that there are 3 barium chloride molecules. And so we're going to multiply the 3 times 1. We know that 3 times 1 is 3. And then we're going to multiply 3 times 2. So 2 times 3 is 6. All right, so in total, we would have 9 atoms here. All right. All right, so now we're going to have to work with one that has a parentheses involved. So we're going to start this one out, again, the same way. So we're going to record the elements we have present. We have chlorine, we have nitrogen, and we have hydrogen. Okay, so the chlorine has this subscript of 2 behind it, so we have 2 chlorine. Now, inside of our parentheses is what we need to figure out first. So there is no subscript behind this nitrogen, so we know that we have an invisible subscript of 1. And then we have a subscript of 3 on our hydrogen. So we know how many of each of these we have. Now we need to do a little bit of multiplication. So that subscript only is going to apply to what's inside of the parentheses. So 2 times 1 is 2. And then 3 times 2 is 6. So that's going to give us a total of 10 atoms in this molecule. So again, when we are working with parentheses, we figure out what's inside first, just like you would do in math class. And then you're going to do this, multiply the subscript by everything inside. All right, and last but not least, we have one more we're going to work on that has both parentheses and a coefficient. So we're going to record our elements: aluminum, sulfur, and oxygen. So we're going to start on the left-hand side, just like we read. So we see that we have a subscript of 2 here, and we're going to go ahead and record that. Inside of our parentheses, we have 1 sulfur, and then we have 4 oxygen. That parentheses does not have a coefficient outside of it, so we don't have to do anything extra and special with that. Now, we're going to start looking at our coefficient. So with our coefficient, we're going to multiply the 4 times all of the other numbers that we have here. So 2 times 4, we have 2 aluminum, but we're going to have 4 molecules of this, so we're going to multiply by 4, which will give us a total of 8. Then we're going to multiply, so we've done this one. Now we have to do this one. This is just like the distributive property in math, guys. So 4 times 1 is going to be 4. And then last but not least, 4 times 4 is 16. And that's it, guys. All right, thank you so much. I'll talk to you later.